Hello and Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today we will present about integrated design project. We are from section 7 and group 2. Before we start, I would like to introduce our group member. First, Frenzil Anak Kadok. Second, Muhammad Badrul Hisham. Third, Jamalul Mustafa bin Samad. Fourth, Siti Shazwani binti Zakaria. And last, Chan Shun Hao.
To ensure its availability and affordability, the first thing we need to do calculation and stimulation was the stick. Firstly, we have assumed that force applied on it is 50 Newton, and by using the torque and movement formula, which the T equal to Fd and M equal to Fd, we can know that the torque is 8.6 Newton meter, and the movement is 48.615 Newton meter. When we have this data, we can calculate the normal stress and shearing stress on it. After calculation, the normal stress we get is 61.8985 megapascal, and the shearing stress was 5.475 megapascal. Indirectly, we can done calculation on the principal stress. The maximum stress was 62.379 megapascal, and the minimum stress was 0.4805 megapascal. And lastly, the average stress was 31.4298 megapascal. After we get the average stress, we can use it to calculate the factor safety, which get the factor safety is equal to 8. The definition of the safety factor is simple. It is defined as the ratio between the yield strength of the material and the design stress in the part. The higher factor safety means the structure is safer to load coming on it. Next, we need to calculate the stress on the container. Firstly, we assume that the mass of rubbish is equal to 1 kilogram. By using the stress formula, stress is equal to the force over area. We get that the stress is equal to 181.667 Pascal. From the alright results, we can get that the yield strength of aluminium was 240 megapascal. Now, we can calculate again the safety factor of it by using the same safety factor formula. For board calculation, we use the standard style of board, which is M10, and the diameter of it is 10 mm. Next, the tensile stress and the measured diameter area of fastener can get from the table 3.1. Based on the data above, we can calculate the bolt stiffener KB, member stiffener Km, stiffener constant Kc, period bolt F, and proof load FP. After having this result, we can do safety factor analysis to find the yielding safety factor. Finally, the yielding safety factor is equal to 1.3333. When a factor of safety is greater than or equal to 1, this means the applied stress is less than or equal to the maximum stress, so the object can withstand load.
For calculation versus specification target, in calculation, the product size is bigger than specification target, which is 47.5 times 30 times 97.3 cm. Mostly, the material that we will use is steel, so it's heavy than the specification target. For the application, our product is applied to outdoor cleaning compared to specification target, which is applied to indoor cleaning. Our cost is more cheaper than specification target, which only costs RM125.
For analysis and discussion, we conduct the analysis by using mathematical calculation. Each part of our product have force applied on it. So, based on the force that apply on the part, the mathematical calculation for the part can be calculated to identify whether failure can occur or not and to find the factor of safety. The value of factor of safety obtained will determine whether the product can handle the stress on them or fail, the product fail. Okay, for the first part is the stick. By assuming the force on the stick is 1 Newton, we obtain the torque of 0.172 Newton meter and moment value is 0.9723 Newton meter. Okay, by using the torque and moment value obtained, the normal stress value is 1.2379 megapascal and the shearing stress is 0.1095 megapascal. The maximum principal stress obtained is 1.2475 megapascal and the minimum is 0.0096 megapascal. For the factor of safety obtained from the calculation is 581.583. For the next part is the container. We assume the mass of the rubbish is 1 kg. And by assuming the mass of the rubbish is 1 kg, we obtain the stress of the container is 181.667 megapascal. And for the yield stress of the aluminium container is 2.75742 exponent 07 Newton per meter squared. And for the safety factor is 16.6452. For design improvement, after we have done the simulation computer for our product, we identify that we can improve our design to increase the efficiency and make the customer feel better when use it. Okay, for the first one is for the stick. We can replace the material of the stick from carbon steel to aluminium because aluminium it is more lighter and easy to handle for the customer to use it. Okay, the second one is we redesign the body a bit wider to increase the its capacity to store more waste. Okay, for the next one is for both body and container, we use aluminium 1060 alloy. The material used for the body also can be changed from aluminium to magnesium alloy to reduce the weight of the product. Okay, for the container, after we redesign the body, we must redesign the container also to match with the body to avoid unnecessary space to be waste. Okay, for the brush, we can improve the efficiency by using microfiber material to help clean the area safely and effectively. Okay, for the last one is the battery. The battery can be improved by using lithium battery, even though lithium battery are much more expensive from compared to lead acid battery, but they are maintenance free and have a longer lifespan to match their higher price tag.
Number 1, stick. After we are discussing among our member and we are looking for the design improvement, we decide to design our stick like this. Our stick diameter is around 20 millimeter and the length of the stick is 972.32 millimeter. The material of the stick is carbon steel and we need 2 quantity of this stick. Number 2, body. From this drawing, we can see the width of this body is 400 millimeter. The height of this body is 300 millimeter and the length of this body is 475 millimeter. The material of this body is aluminium alloy 1060 and the weight of this body is around 49 Newton. Number 3, container. From this drawing, we can see The length of this container is 250 mm, the height is 280 mm, and the width is 370 mm. The material of this container is same like the body, which is aluminium alloy 1060. Number 4 is brush. Look at this drawing. We can see the length of this brush is 330 mm, and the diameter we are used is 37 mm. This is the main brush, and the material is from the plastic. The main brush is placed at the front of our project. Next, number 5, we will look at the side brush. The length of this brush is 85 mm, and the diameter we use for this brush is 40 mm. The material of this brush is same like the main brush, which is plastic. This brush is placed at the side front of our project. Number 6 is a motor. Our project use 3 motor to move the 3 brush. Motor we are use is a motor DC, and the material of this motor DC is metal. Next, this drawing show the explode view of our product. Look at the bill of material table. Our product have 7 items. First, container 2, used to place the trash. Number 2, container, which is the cover of the product. Number 3, stick, used to handle for controlling the direction. Number 4, wheel, use ability for moving. Number 5, main brush, used to sweeping the trash. Number 6, driver motor, used to providing torsion at the brush. Number 7 is side brush, used to sweeping the trash at the sides.
For the project management, we manage our schedule until week 13. From first week until third week, we do the project planning, which is design idea yielding, and project management. From week 4 to 5, we finalize our proposal, design concept overview, and do stage design sequence. For week 6 until 7, we done our product specification, working mechanism, and do the calculation based on ANSYS. From week 8 until 11, we done our design improvement, design outcome, project management, simulation mechanism, video, and the presentation. The last 2 weeks, we done the report submission and submit it.
For the finance, steel plate and steel rod is provided by the faculty. We need 2 brushes, which for main brush and side brush, which is cost 5 ringgit each. Since this trash collector is rechargeable device, we need a battery, which 55 ringgit. In order to move the brushes, 3 motors are needed, which cost 3 ringgit each. We need 4 wheels to move the device, so it is cost 5 ringgit each. To connect the battery and motor, we need the multi-core wire and rocker switch, which cost 4 ringgit. So the total item that we had surveyed is 125. In conclusion, after we calculate and simulate of each part, the design can be improved to increase the efficiency, such as reduce the weight and to avoid the failure. We also include the drawing that we redesign in design improvement. We also update the Gantt chart to the latest progress.